Hi, welcome to this tutorial. Here we have two equations involving logarithm to solve for x. The first one, 3 log x base 7 is equal to 2 log 7 base x plus 5. If we look at the first one very well, we see that here we have log x base 7, but here it has been reversed. It is now log 7 base x. And so to be able to solve this equation very well, we need the rule on change of base. We need the rule on change of base which says log a base b is equal to 1 all over log b base a. We need this rule of change of base in order to solve the first equation. All right, so the choice is yours. You either put all to base 7 or you put all to base x. All right, now I have chosen to put all in base 7. This one is already in base 7, and so I repeat it the way it is. 3 log x base 7 is equal to 2. Now, to bring this to base 7, I apply that law. The argument becomes the base, and the base becomes the argument. So it becomes 1 all over log x base 7 plus 5. Okay? Now, this is what we finally obtain. We have arranged everything to have the same base, base 7, base 7. And again, the arguments are the same. So, we obtain an equation in this nature, but it's not very obvious or clear how this can be solved. The best way forward is to carry out the transformation wherein we can bring in a new variable, say y, and call it to be log x base 7. This transformation, when we use it, we can transform this equation to a much more clear expression that we can solve. All right, let us put the value of y there. Let us put the expression for y there. So it now becomes 3y is equal to 2 into 1 all over y plus 5. All right, this is 3y is equal to this 2. Since this is a fraction, it's always advisable to do like that to avoid mistakes. So that we can see, we take the numerator multiplied by the numerator and then denominator multiplied by the denominator. Don't make the error where someone will take this multiplied by the numerator and take this and multiply by the denominator. It's not correct. If this is a fraction, we can always make this a fraction so that we take numerator, numerator, denominator, denominator, plus 5. All right. Now, if we multiply all through by y, we're going to do away with this denominator. We're going to have y into 3y is equal to y into 2 all over y plus 5 times y. So that this y cancels. We now have 3y squared is equal to 2 plus 5y. Okay, if we take everything that is on the right hand side to the left hand side, then we're going to obtain the quadratic equation 3y squared minus 5y minus 2 equals 0. Look at it. What we're given up there is actually this quadratic in another form. So we now see the true nature of that equation up there. It is actually a quadratic in terms of log x base 7. Okay, to solve this quadratic, we know we collect our terms. A is 3, B is negative 5, C is negative 2. Okay, so what is AC? AC is 3 multiplied to negative 2, which is negative 6. So we get the factors of negative 6, plus minus 1, plus minus 2, plus minus 3, plus minus 6. The factors of negative 6 are 2, 4, 6, 8. There are 8 of them. Now we'll look in this list and bring out just 2 elements from this list such that their product is negative 6 and their sum is negative 5. That choice can only be negative 6 and 1. Negative 6 multiplied to 1 is negative 6. Negative 6 added to 1 is negative 5. That's the only correct choice. Now we're going to rewrite this equation. Putting negative 6 and 1 in the place of negative 5. Okay? Now let's go back up there and create more space. Okay, so we rewrite that equation. So we have 3y squared. In the place of -5, we're going to put -6 plus 1y, -2 equals 0. Now we open out this with respect to y. We have 3y squared minus 6y plus y minus 2 equals 0. Now we factorize the first two terms and the next two terms. When we take the first two terms, we have 3y is common. When we remove 3y from here, we're gonna get y. Or remove 3y from here, we're gonna get -2 plus y minus 2 equals 0. Okay, you can always check to see if your factorization was correct. If you try to open this bracket, 3y multiplied to y is 3y squared. 3y multiplied to -2 is -6y. So this factorization is correct. Again, now at this level, we have y minus 2 is common. So we continue with our factorization, y minus 2. When we remove y minus 2, we are left with 3y. We remove y minus 2, we are left with +1 equals 0. Okay, now at this point, either y minus 2 is 0, which therefore means that y equals 2, or 3y plus 1 equals 0, which means y equals -1/3. Now, we were not asked to solve for y. We were not asked to solve for y. We were asked to solve for x. All right, so this does not mark the end of this solution. So to get the value of x, we go back to this substitution that we made earlier. This is a relation between y and x. The relation is y equals log x base 7. So we're going to substitute these values of y in turn to get our corresponding x. So when y is 2, we have 2 equals log x base 7. This therefore means that 7 raised to the power 2 will give us x. Okay? This therefore means that x is 7 squared, which is 49. So our first value for x is 49. All right? And then when y is -1/3, we have -1/3 is equal to log x base 7, which also means therefore that x is equal to 7 to the -1/3. So those are the two values for x in this first equation that we're supposed to solve. Okay? Okay. Now let us look at the second equation. Let us look at the second equation. The second equation says log the base 5 of x cubed plus 3 log 2 base 5 is equal to 0. Okay, so let us first of all write everything in simple form. So this is log the base 5 of x cubed plus log 2 cubed. This 3 is actually the power of 2 base 5 is equal to 0. So this gives us log x cubed base 5 plus log 2 cubed is 8. Base 5 is equal to 0. Okay. Now, the addition law says that we actually multiply. So the bases are the same, base 5, so it becomes 8x cubed. We multiply this and that. 8x cubed is equal to 0. And we are to solve for x. Now, we know that if we have an expression of this nature, it simply means that when we raise this base to this power, we are going to get the argument. So this means 5 to the power 0 is going to give us 8x cubed. 5 to the power 0 is 1. Anything raised to the power 0 is 1. So we have 8x cubed. Now, to, to solve for x, what do we need to do? We need to solve this equation. So the best thing to do is to bring this one to the right hand side. So that we'll have 0 here is equal to 8x cubed minus 1. This is positive 1. When it comes this way, it becomes minus 1. So we'll have 8x cubed minus 1. Now, look at it carefully. We'll see that uh, 0 is equal to, this can be written as 2x, all of that cube, minus 1 cube. So that at the end of the day, we see a difference of cube coming up here. 8 is the same as 2 cube. Right? And 1 can be written as 1 to any power. But we have chosen 3 here so that we can use an identity that we know, the identity of difference of cube, which says a cube minus b cube is the same as a minus b into a squared plus ab plus b squared. This is the identity that we are going to use to solve this equation. So this right hand side here resembles this left hand side. So we want to transform everything to the left hand side, the nature of the left hand side. Our a is 2x and our b is 1. So let's follow it here. Wherever we see a, we put 2x. Wherever we see b, we put 1. So this stuff here can be written the same as, this stuff, all of this can be written the same as 2x minus 1 into 2x squared plus, remember wherever we see a, it is 2x. 2x times 1, b is 1, plus 1 squared. Okay? Now, this gives us 2x minus 1 into 2x squared is 4x squared. 2x multiplied to 1 is 2x plus 1. All of that equal to 0. So we have the product of this and that giving us 0. Therefore means either this is 0 or that is 0. So either 2x minus 1 is 0, which therefore means that x is a half, our first solution, or 4x squared plus 2x plus 1 equals 0. Here we have a quadratic to solve in terms of x. Okay, now let's solve that quadratic. Let's use the quadratic formula this time around. Our a is 4, our b is 2, and our c is 1. Let's use the quadratic formula. X equals negative b plus minus the root of b squared minus 4ac all over 2a. So we have x equals negative 2 plus minus the square root of 2 squared minus 4 into 4 times 1 all over 2 times 4. So this gives us negative 2 plus minus the square root of 4 minus 16 all over 8. 4 minus 16 all over 8. Okay, so we have negative 2 plus minus the square root of negative 12 all over 8. Now, negative 12 can be written as Negative 12 can be written as negative 1 times 12, so that the square root of negative 12 becomes the square root of this, which is square root of negative 1 times square root of 12. And the square root of negative 1 is I. And square root of 12 is square root of 12 is square root of 4 times 3, which is I into square root of 4 square root of 3, which is 2I root 3. Okay, so the two values of x there are negative 2 plus minus negative 2 plus minus the square root of negative 12. We write that plus minus I 2 root 3 all over 8. All right, now 2 can cancel all round because 2 here 4, 2 here 1, 2 there 1. So that gives us x equals negative 1 plus minus I root 3 all over 4. Okay, thus our solutions, since it was a cubic expression means we must have three solutions. We have the first solution, x equals a half. The second solution, x equals negative 1 plus I root 3 all over 4. And the third solution, x equals negative 1 minus I root 3 all over 4. These are the three solutions of the cubic expression that we had, and which also translate to the solution of the equation involving logarithm that we had at the beginning.